Question 34, we have the rational inequality and we need to solve it. So notice how the rational inequality has the denominator that needs to be factored. So we're going to write it as x minus 6 over x minus 8, x plus 8 less than 0. Now the critical values are, from the numerator, x minus 6 equals 0, and that is going to give me x is equal to 6. I'm going to box that. And then from the denominator, I have x minus 8 equals 0. That gives me x equals to 8. So I'm going to circle that. X plus 8 equals 0. That will give me x is equal to negative 8. On the number line now, an open number line, I'm going to begin with the smallest number, which is negative 8, and that is not included. So I'm going to have a dotted line there. And then 6 goes next, and that is also dotted because the sign, the inequality sign, doesn't have an equal. And then the last one is 8, which is going to be dotted as well because it comes from the denominator. So now I'm going to pick a testing point, negative 9 from the first interval, 0 from the second interval, 7 from the third interval, and 9 from the last interval. So if I plug these testing points into this factored form, I will get negative in the numerator over negative in the denominator, and then negative. The other factor is negative as well. I have 3 negatives, which makes this interval negative. If I plug 0, I will get negative in the numerator, and the first factor in the denominator is negative. The second factor is positive. 2 negatives makes positive. So the second interval is positive. And then if I plug 7 into the numerator, I will get positive. And then in the denominator, I will get negative and then positive, which makes this interval negative. If I plug 9, I will get positive over positive over positive. So everything is positive, which makes the inequality positive. I'm looking for anything that makes the inequality less than 0, which means it makes it negative. So here we go. This is one interval, that is the solution, plus the other one. We can rewrite it like this. We can say the first interval goes from negative infinity to negative 8, union. The second interval goes from 6 to 8, and open on both sides of the interval. 35, we're going to solve the inequality. It is factored and ready, so we're going to find the critical values. So x minus 1 equals 0, and that will give me x is equal to 1. I will box it because that is coming from the numerator. X plus 8 equals 0. That will give me x is equal to negative 8, which is coming from the denominator, so it's going to be excluded. X minus 7 equals 0, and that is going to give me x is equal to 7, which is also excluded. Now I'm going to make an open number line, and I'll begin with the smallest number. It's tilted, let me fix it. Negative 8 is the smallest number, and then 1, and then 7. Only the 1 is included, so I'm going to put a closed circle here so I know, and I'm going to include a solid line there with the other ones. I will change the color, so it's going to be dotted line and dotted line because none of these are included. I will choose testing points. Negative 9 is less than negative 8, 0 between negative and positive, 2 is bigger than 1, and 8 is bigger than 7. So if I plug these testing points into the factored form, I will get negative in the numerator over negative in the denominator, and then negative again. So it's going to be not negative 1, just negative sign. So this is going to be negative. If I plug 0, I will get negative in the numerator, positive, and then negative. Two negatives makes positive. If I plug 2, I get positive in the numerator, positive in the first factor, and negative in the last factor, which is going to make this negative. If I plug 8, I will get positive in the numerator, positive in the denominator, first factor, and positive in the last factor, which is going to make this positive. Since I'm looking for everything that is greater than or equal to 0, so I will include all of the positive intervals, which is this interval right here and this interval right here. So the solution is going to be from -8, and it ends at 1, inclusive 1, union. It starts from 7, it goes all the way to positive infinity. So this interval. Number 36, I'm going to find the critical values. So x minus 2 equals 0. That will lead to x is equal to 2. This comes from the numerator, but it's excluded because this sign doesn't have an equal sign. X is equal to 0 is another critical value. And then x minus 6 equals 0 will lead to x equals 6, and that is the third value. Let me actually make it equals 6. Now, the number line, open number line, I will begin with the smallest number, which is 0, and then 2, and then 6. All of them are excluded. So I'll put dotted line here, dotted line there, and dotted line there as well. I will pick testing points before 0 or less than 0, -1. Between 0 and 2, 1 would work. But between 2 and 6, 3 would work. And bigger than 6 is 7. Now I'm going to plug these testing points into the factored form here. So this is going to give me negative in the numerator, negative in the denominator, and the other one is negative. So 3 negatives will make negative. If I plug 1, I'll get negative in the numerator, and then positive, the first factor. The second factor is negative. 2 negatives will make positive. If you plug 3, you get positive in the numerator, and then positive in the denominator, and the second factor is negative. So that's negative. If you plug 7, you get positive over positive times positive. So this is positive. We are looking for all of the intervals that makes it less than 0, which is the negative intervals. So that is the solution. So I can say that the solution is from negative infinity to 0, open, union from 2 to 6, all open. None of these critical values are included. And then 37, I will find the critical values. X plus 4 equals 0. This will lead to x is equal to -4 coming from the numerator, and it's included. X minus 7 equals 0. That will lead to x equals 7, and it's excluded because it comes from the denominator. The first one is included because of the equal sign. Now we're going to use the open number line. -4 is smaller, and closed, and negative, and then 7. So this is actually open. That's one solid line. And this one is excluded, so it's dashed line. Before -4, we have 0. We have, -5. Between -4 and 7, 0 be after 7 or bigger than 7, we have 8. Again, plug this into the factored form. You get negative over negative, which is going to be positive. And then we have positive over negative, which is going to give me negative. And then we have positive over positive, which is going to give me positive. So we're looking for anything that makes the inequality bigger than 0. That is all of the positive intervals. So that interval plus that interval. So the solution is going to be from negative infinity all the way to negative 4 inclusive of 4 union, from 7 exclusive to all the way to positive infinity. Number 38, notice how number 38 does not have this side 0, so that would be the first step that you will do. You're going to add 1 to both sides of the inequality. You get x plus 8 over x plus 2 plus 1 greater than or equal to 0. That will be the first step. Now we need to have a common denominator, so we need to multiply the 1 by, let me just erase that. So plus 1 greater than or equal to 0. We need to multiply the 1 by x plus 2 over x plus 2 to make it have common denominator. Now we can rewrite that inequality as x plus 8 plus x plus 2, because if you distribute the 1 inside, it's the same, over 1 denominator, which is that, greater than or equal to 0. So now we're going to compute the critical values. 2x plus 10 equals 0. That will lead to 2x equals negative 10, x equals negative 5, x that is included because of the equal sign. X plus 2 equals 0. That will lead to x is equal to negative 2, which is excluded because it comes from the denominator. And now the open number line, you will have the negative 5 and it's included, so solid line there. And then negative 2 here, which is dotted, it's excluded. The testing points are going to be negative 6 and then negative 3 and then 0. So if you plug negative 6 into the last form that we created, don't plug it into the original one because the original one doesn't have the right-hand side 0. So negative 6 is going to produce negative, which is negative 12 plus 10, that is negative 2 over negative 4. So negative over negative is positive. And now, negative 3, that gives us negative 6 plus 10, positive, over negative, which is going to give me a negative interval. And then the 0 is going to produce positive over positive, which is positive interval. This interval must be greater than 0, so the intervals that are greater than 0 are these two intervals. So the solution is going to be from negative infinity to negative 5, inclusive of 5, union from negative 2 to positive infinity. And that is the end of the exam 1 review.